Imagine Petronas Towers, the jewel of Malaysia, ranking at 9th tallest skyscraper of the world. The walls of it has an area of roughly 130,639 meters square. That is like 18 football fields. It's an area that can be painted by our SCYPA, area that we can use to generate electricity and absorb carbon dioxide. Hi, I'm Faris.
And I'm Alanna.
We are two A-level students and proud researchers of our idea,
the SCYPA, or Solar Cyanobacteria paint.
Here in KYUEM, we have formulated a novel method of generating electricity, a type of solar paint. How? We incorporated two fundamental concepts, which are biophotovoltaic cells, also known as BPV cells, and hydrogels. BPV cells are an alternative method of harnessing solar energy by exploiting the properties of autotrophic microorganisms such as algae and cyanobacteria. A BPV cell extracts electrons released from hydrolysis, a process of splitting water molecules done by said microorganisms for photosynthesis to take place.
Meanwhile, hydrogels are cross-linked polymeric networks that can hold large amounts of water, including the microorganisms for our BPV cell. We chose hydrogels in particular because of their tailorable physiochemical properties, depending on the many materials and methods, which allows us to produce a paint-like texture, capable of competing with paints on the market. In our research, we're trying to produce a conductive, adhesive, low evaporation and self-healing hydrogel. Basically, our research focuses on the applications and properties of a BPV cell encased in hydrogel. Fun fact, the largest solar power plant in Malaysia takes up 980,000 meters squared of land that can be used for residential, agriculture and even the original forest that grows there. But with our product, we can cover the same area for no amount of land. Imagine the magnitude of electricity we can produce with all the tall buildings of Kuala Lumpur.
Hence, a lot of problem statements and questions arises, such as, what is the efficiency of SCYPA compared to conventional BPV cell designs? Is it better?
These are the essential questions we are trying to address through our very long methodology. Rest assured, the data we're collecting are proving very promising, such as a maximum recorded potential difference of 0.102 volts, slightly more than most published papers on BPV cells.
What are our objectives? Well, we want many things, but mainly
to produce an alternative environmentally friendly hydrogel-based paint that both produces electricity and absorbs carbon dioxide, to provide an alternative cheaper method to generate electricity from solar energy, to reduce the amount of carbon dioxide emissions to the atmosphere, sort of a CO2 sponge, also to reduce the effects of urban heat islands in cities.
Meanwhile, the novelty of our idea lies in SCYPA's ability to generate electricity using a new method.
Its ability to solve many environmental problems simultaneously, such as high carbon dioxide emission, high demand of electricity, high temperature from climate change, and more. Also, SCYPA does not need actual land to produce electricity since hydrogel is utilized as a paint medium. Finally, the most noteworthy, the doping of algae into hydrogel, which has never been done before.
A world with SCYPA would benefit the society by providing a healthier and clean environment for generations to come, reducing the cost of electricity generation by solar energy, providing a clean renewable energy source, reducing high temperatures in cities, and reducing the negative environmental impacts of the manufacture of some traditional solar systems.
We envision our idea to become a paint company which provides mass production of our SCYPA for both local and international use.
Did you know that the market for paint is $160.03 billion in 2021? Thus, a novel electric generating paint would surely be able to compete in this ever-growing market.
Moreover, SCYPA is very adaptable to meet certain demands since hydrogel itself is very tailorable.
Similarly, cyanobacteria is also adjustable in terms of genetic modification.
For example, in the future, we can cater to not just buildings, but boats, ships and airplanes as well, in a variety of interesting colors similar to paint on the market.
We believe an effective BPV cell encased in hydrogel, SCYPA, is very feasible and can increase Malaysia's production of solar electricity significantly. With SCYPA, we are creating the future of solar technology.